Hey everybody, this is Mr. Munson. We are starting Unit 8, which deals with special quadrilaterals, and this video is going to cover the concept 1, basic quadrilaterals and parallelograms. This video is dedicated to my man Kevon in second period who loves spaghetti. Just look at that plate. That looks so good. Let's get started. Or you feel free to put me on pause, stare at the incredible creation, and then come back when you are ready to get started.
Okay, so as we go into this section of Unit 8, we're going to be dealing with different types of shapes. And I'm just going to go something to a chart that you've probably seen before or something like it. So if you take a look at this, you'll see that there's different types of systems, if you will, like the plants, animals, fungi, protists, all those things. And so this one's kind of focusing in on animals. So animals is a separate category than, of course, plants. So when we look at the world of animals, animals can be broken up into these vertebrates and invertebrates. And so when we start talking about invertebrates, we automatically know we're talking about animals because that's the kingdom that we're pulling from. Now, if we would come down here to mammals and we start talking about mammals, we know that we're not only talking about just mammals that have a certain characteristic that separates it from vertebrates, it's still an animal. Okay, so this is kind of the thread that takes you down to animals. Okay, so if I was talking about insects, what I know is all insects are arthropods that have invertebrates that are part of the animal kingdom. So this represents right here its kind of genealogy, or its lineage, right? And so insects have all the characteristics of arthropods, invertebrates, and animals, um, but maybe something special that makes it an insect versus let's say, a crustacean. We're going to look at this chart, and we've looked at it. If you watched the video on vocabulary, we've already seen this chart. So basically, we're looking at quadrilaterals in this chapter, right? Quadrilaterals have four sides, and that's basically the thing that separates it from being, let's say, a pentagon or a triangle, okay? Now, in the world of quadrilaterals, there's just some everyday quadrilaterals, four-sided figures, but some have some special characteristics that we're going to be looking at. These here are called trapezoids. This kind of like vein of quadrilaterals, they're trapezoids, and they have two parallel lines, and that's it, no more, two parallel lines. Now, another vein is this, and this is the world of parallelograms. This is what we're going to look at today. But parallelograms have two pairs of parallel sides. And then finally, when you get over here, we're going to be looking later on in another video about kites. All right, so let's go ahead and start our notes if you haven't already. And we're looking at section 8.1, quadrilaterals and parallelogram basics. So quadrilaterals, by definition, are polygons with four sides. Okay. Now I'm going to introduce a couple of words here, convex and concave. These are from previous years of experience. Hopefully you've had these words. On your vocabulary sheets, they're not there, but you're welcome to put these words in the vocabulary, the blank spots at the end, okay? So convex are polygons that basically I like to describe in a very simple way. They're polygons where kind of all the sides push out. Versus if you look at the concave, there's sides that can be pushed in. A star is another example of a convex, or I'm sorry, concaved. That's a horrible star. Concave polygon. In the world of quadrilaterals, every quadrilateral, this is just your basic quadrilateral, has no special features to it. But in this quadrilateral, what we find out is that, it certainly has four sides, but then the sum of the interior angles equals the same number, a certain number. And it's always the same number for every quadrilateral. We've learned this from chapter 1. But for a triangle, of course, it's 180 degrees. For a rectangle, certainly we can calculate it using the sum of the interior angles theorem, n minus 2. So we calculate that, and 2 times 180 ends up being 360 degrees, right? That's the sum of the interior angles. Now that's a clue of what kind of equation we should write here. Go ahead and put me on pause, see if you can write an equation, solve for x, and then solve for x. See you in just a bit. All right, and if I've done my math correctly, I set up the equation that the sum of the interior angles equals 360. So I just substituted these words right here for all the pieces over here, right? The sum of the interior angles, that's what all that represents, right? The sum of the interior angles equals 360. So I work it down and it should come out to 46.4 degrees. Okay? All right. You know, when I go to the car wash, sometimes there'll be several different variations I can get for my car wash. You know, there's the basics, and then there's the bonus or whatever, and then there's the next one, and so on. And when I get the basic, it gives me a list of all the things that are going to happen to my car through the car wash process. And then after that, the next line up, it might say the bonus wash. And the bonus wash will have the word basic, so it has all the features of the basic, and then it'll list all the specific things that make it different than the basic. And then you might go to the grand card wash, and the grand card wash will have in there the, you know, the next line that it just came from, plus all the new features that make it a different car wash experience. So same thing as I'm writing this, parallelogram is parallelogram, you know, is it's a four-sided figure. So it starts off, we already know it's a quadrilateral, but now so it has all the features of a quadrilateral, all the angles add up to 360, but it has additional features. So let's talk about those. So the main feature, the one that sets it apart from all the other quadrilaterals in the bunch, is that it has two pairs of parallel sides, right? So we'll say this is a pair, and the other set of sides are these. Remember, we use these arrow-looking things to represent parallel sides. Okay, that is by definition what makes it a parallelogram. Now, when we take a regular quadrilateral, like we had just a regular quadrilateral here in this one, we would take a shape like that and make sure that the opposite sides are parallel, some really neat features come about. So we want to look at these features. They're going to either have something to do with the sides, the angles on the inside, and the diagonals. So let's quickly go through these. In the sense of the sides, what we find is that the sides are congruent to each other. They're not only parallel, they're congruent. Now that's a hint to what kind of equations we'd write. So if I tell you one is 5x plus 3 and another one is 2x minus 1, we'd set those things equal to each other to find x. All right, consecutive angles, which this one right here, this little green one right here, that green one and this angle right here are consecutive interior or consecutive angles. And they're definitely interior angles of this shape, right? Now what we find is we're wondering what's the relationship these two have? And this takes us back to the parallel line stuff that we did a long time ago. We have this angle right here and this angle right here. Those consecutive interior angles back in Unit 3 were supplementary. And the same thing is going to be true here. These pair of angles are supplementary angles, are consecutive interior angles, and therefore they're supplementary. They add up to 180 degrees. Let me show you another pair of supplementary angles. So these two are supplementary angles. Okay. Now, if you're not sure why they're supplementary, you need to go back and look at the vocabulary words because we've dealt with that, and just make sure you understand that. Okay. So consecutive angles are supplementary. Okay, and again, that's a clue of what kind of equations we'd write if we knew information about those angles. So if we saw that this one was 120 degrees, we certainly could find this one down here by realizing that they're supplementary, right? So that leaves us a 60-degree angle for that one. Now, this angle right here, the 60, and this one over here are consecutive consecutive interior angles. So we know that this pair of angles are supplementary as well. Well, that leaves that one to be 120, just like the other one. Okay? Now that opens up a whole nother characteristics that hopefully you see, and that is that opposite angles are supplementary. I'm sorry, not supplementary, but congruent. And then finally, what we're looking at is the diagonals. When we draw the diagonals, what we find out is that there's a characteristic of those. What we find is the diagonals actually, when they intersect, they create a point, of course, but they bisect each other. They cut each other in half. This is a cool thing, so let's go ahead and note that. All right, very good. So the diagonals bisect each other. Now let's get this in order real quick. Okay, so in a parallelogram, opposite sides are parallel. Okay? And then also, opposite sides are congruent. Okay, so consecutive angles are supplementary. So just take a look at these two. These are right next door to each other. Their sum is equal to 180. If you take the top two and look at them, those should equal 180. In other words, add them up, make it equal 180. That's a hint of what type of angles or what kind of equations we're going to be writing. Opposite angles are congruent. There's the pair of opposite angles that are congruent, right? So that tells us we can set those expressions and stuff equal to each other. And then finally, the last one, the diagonals bisect each other. Okay? So that piece would be congruent to that piece would be congruent to that piece. And that's it. Let's go ahead and draw your line, do your summary. Let's go through these several do it problems. Let's bring that to class next time. I'll scroll in on them so you can see them. And there you have it. Have a great day.